As a way of introduction to our lesson today, why is it tricky to think about the cosine of 100 degrees? Why is that tricky? What's the definition of the cosine? What's the definition of the cosine? It is the ratio of the adjacent side to the hypotenuse in a what? What kind of triangle? A right triangle. So that makes thinking about the cosine of 100 degrees a little bit tricky, doesn't it? Why is it tricky? Can you have a 100 degree angle in a right triangle? You cannot. Okay? You cannot have if we're talking about the sine of 240 degrees. It's a little tricky because the sine is defined to be the ratio of the opposite side, the hypotenuse of a right triangle. For heaven's sake, you can't have a 240 degree angle in a right triangle. All right? So we're going to use our knowledge of trig ratios, reference angles, and reference triangles, the stuff that we just tested on in test 1. We're going to bring it to specific angles in test 2. So we can talk about the cosine of 100 degrees because it's going to have a relationship with the cosine of the reference angle of 100 degrees. All right? 100 degrees is in which quadrant? Second quadrant, so we know that the cosine of 100 degrees is negative. We at least know that because only the sine is positive in the second quadrant. So we're going to be putting together a lot of the things that we've talked about up to this point. So let's review a couple of things first. The chart that you're going to have the quiz on tomorrow, all the denominators are what? 2. So our special angles are that. I'm going to give you this framework tomorrow. All the denominators are 2. All the numerators have square roots. And it looks like that. All right, then you simplify those, and tangent is sine divided by cosine. And because everything's over 2, the over 2 parts just cancel out, and you're just left with numerator over numerator. All right, so that's pretty easy to reproduce, and you'll look at that tomorrow. Something else that's extremely important in this class is all trig ratios are positive in the first quadrant. Only the sine is positive in the second quadrant. Only the tangent is positive in the third quadrant. And only the cosine and its reciprocal are positive in the fourth quadrant. Okay? ASTC, all students take calculus. It's not really a true statement. We need to come up with a better one, don't we? But that's the only one I've ever heard for this. Maybe we could come up with a better one. Do all students take calculus? All something TC. That's what we need to come up with. Challenge. Anybody accept the challenge? Nobody? All right. Something else that we need to remember is the concept of reference angles, and this is kind of reviewing what we did in the first deal. The reference angle, by definition, is the smallest angle back to the horizontal axis, closest x-axis. It's always positive. Some of you on the last test gave me negative reference angle values. I think you did one was negative. The reference angle is always a positive angle value because it falls into an actual triangle. All right, and those angles are going to have positive values. No directionality there. All right, and the significance of the reference angle is that the trig ratio of the angle is going to be the same as the trig ratio of its reference angle, except for the sine. The sine may be different. All right, so we're going to be asking ourselves consistently what the reference angle is. So what would the reference angle be for 280 degrees? 80, right? It's the shortest angle back to the x-axis. This is 10 past y, which makes it 80 to the next x-axis, right? So the reference angle here is 80 degrees. The closest x-axis is 360. 5 pi over 6, what's the reference angle? Pi over 6. How'd you do that so quickly? Right. Because when we're dealing with radians, the reference angle for special angles is always pi over the denominator if the fraction is simplified and the denominator is 2, 3, 4, or 6. Okay? Now, this is significant because most of the angles we're going to be dealing with are going to have a denominator. They're going to be in radians, and they're going to have a denominator of 2, 3, 4, or 6. Some of you got a little fooled on the test and took that a little far. There was one of them that was, something pi over 18, and you said pi over 18 is a reference angle because the denominator was 18. I can't remember if that was anybody in this class, but this rule only works if the denominator is 2, 3, 4, or 6, and the fraction is simplified. Okay, so kind of keep that in mind. The reference angle for 5 pi over 6 is just pi over 6. Okay. Now, in our lesson today, we're going to be finding trig ratios of angles that are not between 0 and 90 degrees. So in other words, they're not physical angles of a triangle, a right triangle, right? Because the physical acute angles of a right triangle have to be between 0 and 90 degrees. 100 degrees is not in a right triangle, but we can still talk about the trig ratio of 100 degrees by using the reference triangle. All right, we're going to do this kind of without drawing it. We're going to ask two questions. What quadrant is the angle in? All right. This will tell us the SIGN of the ratio. It'll tell us whether the ratio is positive or negative. They're all positive in the first quadrant, sine only in the second quadrant, tangent only in the third quadrant, and cosine only in the fourth quadrant. The second question we're going to ask is, what is the reference angle? And the reference angle is going to tell us what the ratio is. This is where we're going to go to our table of values that we just did there a few moments ago. If the reference angle is pi over 6, then the sine of pi over 6 is 1/2. And we just have to assign it as plus or minus, depending on the quadrant. So let's go. Cosine of 210 degrees. This is not a calculator active skill. You need to be able to do this without a calculator. Exact values. Cosine of 210 degrees. What are the two questions we're going to ask? What is the quadrant? What quadrant is the angle in? 210 degrees is in quadrant 3, right? Is the cosine positive or negative in quadrant 3? It's negative, so we know the answer is going to be negative. Very important. You could go ahead and write a negative sign beside cosine of 210 degrees, just so you don't forget it. Right? At this point, we know that we're going to have a negative answer, so if you wanted to write a negative there, you could. Okay? What's the reference angle for 210 degrees? Somebody say it. What's the reference angle? 30 degrees. You got to be able to do that pretty quickly. Now we're going to go to our table of values. What is the cosine of 30 degrees? What's the cosine of 30 degrees? The square root of 3 over 2, right? And again, why is it negative? Because it's a third quadrant angle, so it's going to have a negative value there. All right, and this is the skill of the day. Identify the quadrant. That determines positive or negative. Identify the reference angle. That determines the ratio that we're going to be using. Okay? Sine of 135 degrees. Sine of 135 is in which quadrant? Second quadrant, right? You need to kind of get where you can do this as quickly as possible without sketching the angle, but if you have to sketch it, that's okay to do that. This is 90 degrees plus 45 more, right? So second quadrant angle. Is sine positive or negative there? It's positive, so I know my answer here, sine of 135 is equal to a positive. If you wanted to go over there and put a little plus sign there just to make sure that you get that part correct, you're going to be in good shape. So we need to know what quadrant the angle is in. The quadrant of the angle determines whether it's positive or negative. This one is second quadrant, so sine is definitely going to be positive. What's the reference angle for 135 degrees? 45 degrees, right? What's the sine of 45 degrees from the table? Square root of 2 over 2, and it's positive, so that is it. Now what we're doing here is kind of a shortcut to drawing the triangles. Like in the first test, we drew the triangles. And we could still do that because we know that this, that's miserable. We know that this triangle, right, is 1, 1, square root of 2, and we could do negative 1. We could do the opposite over hypotenuse and rationalize and get square root of 2 over 2, but we're shortcutting that using the table of values. Okay? What about this one? Tangent of 330 degrees. Tan of 330. Tangent of 330. What are the two questions we're going to ask? What quadrant is it in? That determines whether the answer is positive or negative. What quadrant is 330 degrees in? What? Fourth quadrant. Right? Fourth quadrant. What's the reference angle? Tangent is what in the fourth quadrant? Tangent's negative. So we know our answer is going to be negative. What's the reference angle? Somebody say it louder, please. 30 degrees. Couldn't tell who said it. 30 degrees is correct. What's the tangent of 30 degrees? 1 over the square root of 3. It's got to be negative. Easy enough? See? All right, cosine of 270. This is going to get us into a little bit of unfamiliar territory. We've not approached this yet. Cosine of 270 degrees. Now, what's immediately different about the angle we're working with here? What 270 degrees?
It's on the y-axis.
It's the bottom of the y-axis, right? So is it in a quadrant? No, it's not in a quadrant. This is one of those, and we defined this early in the course as a quadrantal angle. All right, it's a quadrantal angle. 270 degrees is one of the quadrants. Okay, so if it's a quadrantal angle, and the angle lands on an axis, that's an angle lands on the axis. That's what makes it a quadrantal angle. Then you decide if it is the negative or positive axis to find the sine of the ratio. So it's 270 degrees. Is that on the negative side of the axis or the positive side of the axis?
Negative.
It's on the negative. So any trig ratio down there, 270 degrees, is going to be negative if it has a sign. Keep in mind that 0 can't be positive or negative. If it was 1, then it would be negative 1 if it's down here. All right, it would be positive if it's the top of that quadrant, the top of that axis, negative on the left side of the x-axis, and positive if it's on the right side of the x-axis. All right, so the actual sine of that axis, that side of the axis, determines the sine of the trig ratio. So this one would be negative if it could be negative. What's the reference angle for 270 degrees? What's the angle back to the x-axis here? 90 degrees, right? So our reference angle is 90 degrees. What's the cosine of 90 degrees from the table? 0. Okay? While we're here, let's answer a couple other questions. What's the sine of 270 degrees? Negative 1. All right. We've already answered that we've got a 90-degree reference angle. The sine of 90 degrees is 1. It's got to be negative 1 because it's on the bottom. Okay. What is the cotangent of 270 degrees? Cotangent is 0. Right? Because it's the reciprocal of the tangent of 90 degrees. The tangent of 90 degrees is something over 0, so this one's going to be 0 over something, right? Which is going to be 0. All right? Next one. Sine of 5 pi over 4. Try this one on your own. All right? What quadrant is this in? Third quadrant. 5 pi over 4 is 5 45-degree angles, right? So 5 45s. There's 1, 2, 3, 4, 5. Yep. And the sign is positive or negative there? Negative. What's the reference angle? Pi over 4, right? You don't even have to think about it. It's pi over 4. What's the sign of pi over 4? Square root of 2 over 2. So negative square root of 2 over 2. What's the quadrant? What's the reference angle? The quadrant determines if it's positive or negative. The reference angle determines the ratio that we use. All right? Cosine of negative 5 pi over 3. Cosine negative 5 pi over 3. All right. Questions we're going to ask. What quadrant is the angle in? Where's negative 5 pi over 3, Lauren? Fox? No. What quadrant is negative 5 pi over 3 in? It's almost negative 6 pi over 3, which would be negative 2 pi, right? Just going to put it in the first quadrant. Is that what you said? Quadrant 1. What you were about to say. Quadrant 1, which means it's going to be positive, right? What's the reference angle? Pi over 3. And the cosine of pi over 3 is 1/2. Positive 1/2 because it's in the first quadrant. All right, and again, we're pulling those values off of the table that we are going to be able to duplicate. Okay, now something that's worth pointing out here is that just because the original angle was negative does not mean the answer will be negative. That does confuse some people. All right. The angle, the negative angle, is going to end up in a quadrant, and the quadrant determines whether the answer is positive or negative. All right, last example, then we'll practice a few. Actually, we're going to be out of time. 5 pi over 6, and we're talking about cosecant here. What's cosecant the reciprocal of? Sine. So we're really dealing with sine, right? Sine of 5 pi over 6. What quadrant is that in? So 150 degrees. That's in quadrant 2, and the sign is positive there. What's the sine of 5 pi over 6? Same as the sine of pi over 6, our reference angle, right? Sine of pi over 6 is 1/2, and the reciprocal of that is 2. Now, the only quicker way to do this, guys, is if you actually had a drawing of the unit circle, which we'll create later, or if you can actually see these triangles in your head real quick and see the ratios. And that's fine, too. I said that was the last one. What's the cosine of pi? Pi is what? 180, right? Not in a quadrant. This is one of our quadrantal angles. Is that the positive side of the quadrant or the negative side of the quadrant? It's the negative, the axis. It's the negative side of the axis, so this is going to be negative. What's the reference angle for this pi? 0. What's the cosine of 0? 1. So our answer is -1. All right? We'll pick up right here tomorrow when we get back to class.